We have learned that we can find the area under a function and above the x-axis by taking the definite integral from the lower limit to the upper limit of that function. So that'll get you the area that is below the function but above the x-axis. What happens if you have two functions, one on top of another, and you want to find the area in between those two functions? Well, the process looks like this in the picture that you see in front of you. The first graph shows you, in graph A, it shows you what you want to find. The region of area has been highlighted in blue, and the top function is f and the bottom function is g. The way that's accomplished is by finding the integral of the f function from a to b. That's in graph B. So the integral of f of x from a to b will get you the blue shaded area that you see there, which also includes some space below g of x, right? It also includes some space that is underneath g of x. So that's the big piece of area. Then you want to find the integral of g of x from a to b, and that's going to be what you see in graph C, that region that's shaded in there. So that's considered the smaller piece of area. If you take the big piece of area in graph B and you subtract the smaller piece of area that you see in graph C, you'll get the area that is in between the two functions like you saw in the first graph for part A. That's the idea. We're going to take the integral of the top function minus the bottom function. Top function minus the bottom function, which is written here for you as a shortcut of what's going on. Specifically, it's the area is called A in this case. The area A is found by integrating from A to B the function f minus the function g, and that is assuming that f is on top of g. F is the top function, g is the bottom function. It makes no difference if these graphs stay above the x-axis or if they go below the x-axis or a little bit of both. It does not matter at all. The area will still remain the same. The first thing you want to do now is figure out where the two functions intersect. So it's treated as a system of two equations with two unknowns. And you want to solve that system of equations however you can, maybe substitution, maybe graphing them on your graphing calculator and calculating the intersection points that way. That's acceptable. Step number 2 is to figure out which function is on top and which function is on the bottom. And step number 3 is to set up your definite integral from the lower limit to the upper limit, a to b. And the a and the b that I'm referring to here, those would be your intersection points that you found up above, right? So anyway, the integral from the left endpoint to the right endpoint of intersection of the area. Once again, the top function is first and the bottom function is second, and you subtract the two within that integral. Now, if you happen to switch around a and b, if you put the right limit first on the bottom and then the left limit on top, or if you switch the top and the bottom functions, then your answer is going to turn out to be negative. Okay, so if you switch either of those by mistake, your answer is going to be negative. Area, though, always has to be positive. So your answers for each of these problems in this section and beyond will be positive answers. The area will always be positive, no matter where the functions are placed in the coordinate system, whether they are above the x-axis or below or part above and part below. The quantity of area that's between those two functions will be a positive amount, right? So if you switch around the endpoints, the a and the b, or if you switch the top and the bottom, your answer is going to be negative. So then you'll understand that a mistake was made, one of those two errors was made, and you can fix that to get the correct area for your answer. In the first example, you're given a function f and a function g, and the directions tell you to set up and solve the definite integral or multiple integrals to find the total area of the region bounded by these two graphs. Sketch and label the appropriate graph and check using your calculator. So I'm going to suggest that you begin with a graph. Otherwise, you're not going to know which function is on top and which function is on the bottom. Actually, before that, let's figure out where these two functions intersect. So where do they intersect? This is found by solving the system of equations, y equals x squared plus 8x minus 10, and y equals negative x squared plus 10x plus 14. And so since these are both equal to y, I can write them equal to each other. Therefore, x squared plus 8x minus 10 equals negative x squared plus 10x plus 14. So I'm solving the system using substitution. I want to solve for x now because that's the variable that remains. I'm going to move everything to the left side because I have an x squared term. That means I will most likely be needing to factor this equation to solve for x. And in order to factor, I must have it equal to 0. Okay, so I'm on the road to factoring. I'm going to divide through by the common factor of 2. And now I can factor this quadratic equation pretty easily. Something like x minus 4 times x plus 3. Do a quick FOIL to check to see that you've got it factored correctly. But this gives you the two solutions where the graphs intersect. The x coordinates, positive 4 and negative 3 are the 2 points of intersection, the two x part of the points of the intersections. It's not necessary to find the y coordinates unless you really wanted to. So I'm going to leave it at that. See if you can sketch a graph, is doing as much as possible from what you know without pulling out your calculator. The function f is going to be a parabola that opens up. The function g is going to be a parabola that opens down. Okay, so f opens up and g opens down. And if I remember that the points of intersection are at positive 4 and negative 3. Also consider what those y-intercepts look like. The function that opens up has a negative 10 for the y-intercept. So draw that appropriately. There's where it crosses at negative 10. And then function g, which is the function that opens down, crosses the y-axis at positive 14. So I don't know, that might be a reasonable graph. Now is a good time to check on your calculator just to see how well you guessed. So the 2 points of intersection are located right here. So this was at negative 3 and this one was at positive 4. The area that I'm computing is the quantity of area in between. Like I said, it makes no difference that part of this area is below the x-axis because the total amount of area is still going to be a positive quantity. If you set up the definite integral now, the integral will go from x equals negative 3 to x equals 4. Want to make sure we use our x coordinates on those points of intersection. The top function now is the g function, and that makes f the bottom function. And when you set up your integral, you want to take the top function minus the bottom function. This is all integrated with respect to x, so dx at the end of that. Might want to go ahead and simplify that. Let's go this direction. So from negative 3 to 4, I can distribute the negative through the parentheses, and I can combine like terms, and I'll end up getting negative 2x squared. 10 minus 8 equals positive 2x. 14 plus 10 is 24 with respect to x. And go ahead and take the integral. So you're going to get negative 2/3 x to the third plus 2x squared over 2, so just x squared, plus 24x. And this goes from negative 3 to 4. And when you evaluate this definite integral, you're going to put the top endpoint in, or the top bound in, minus the bottom, the lower bound. So upper bound minus the lower bound. So I want to find negative 2/3 x cubed. Actually, let's do it more specifically. Let's go negative 2/3 times 4 cubed plus 4 squared plus 24 times 4. That's the upper bound minus the lower bound. So negative 2/3 times negative 3 cubed plus negative 3 squared plus 24 times negative 3. And when you work it out, I'll leave the arithmetic to you. You should get the solution 114.33. This is an area, so we'll just call it square units, just to be pretty specific on that. So obviously you've got access to your graphing calculators when you do the test, and also the homework while you're practicing. I would recommend that you, as you're doing your homework for practice, I would recommend writing out all of the steps that you see right here, because on a test question, I'm going to want to see all of this work, and then feel free to use your calculator to check. So what I mean by that is once you get to, let's use this color, once you get to that integral, I would recommend graphing that on your calculator, see what that function looks like, and then do on the calculator here. On the calculator, you would graph y1 equals negative 2x squared plus 2x plus 24. And you'd see that function come up on your calculator, and it's going to go something like this. And then you're going to evaluate the integral. So you're going to go second trace, and that's your calc menu. And you want to be able to see negative 2. Where am I getting negative 2 from? Negative 3 to 4. And that's going to calculate this area that's inside here. Now, it's a different shape than what I originally sketched for this problem because I've changed my function. It's no longer two separate functions subtracted. Now it's just one function. So the quantity of area remains the same, but its shape has changed. That doesn't matter. It's the quantity of area that I want to find. There are ways that you can graph the two separate functions, f and g, on your calculator. And then in a third statement for y3, you could find the difference between the y1 and the y2, whichever is on top and bottom, and calculate the integral from there. But this makes more sense if you just find the difference function and then the integral from the lower bound to the upper bound. And you can check to see that that answer is what you will get. Okay? But it is necessary to use your calculator at this step here to understand that function f is underneath function g in terms of the piece of area that you want to find. F of x is on top, g of x is below it. Wait, I said that backwards. My apologies. G is on top and f is on the bottom.